Okay, I will start now. My name is Stefan Billet. I'm from Coavia GmbH. We are a software consultancy here based in Munich, so this is like our home ground. And we're also one of the proud organizers. My topic for today is autoscaling in Kubernetes. Before that, just a few quick words about our company. We have around 200 engineers. We are based in Germany. We have also some offices in Mainz, Darmstadt, and Rosenheim. And I would say we are primarily a software engineering company. So we build software for our customers, but also we have lots of overlap with platform engineering. So that's also one reason why we are here and why we're also following like the cloud native development since the beginning, more or less. So, about Kubernetes autoscaling. So first I want to tell you where I'm coming from, because I'm a software architect, and when I look at our project in the company, we usually have two camps where what we use as a platform for the software. One side is directly on Kubernetes with the full flexibility. This is, I would say, our default for the bigger enterprise applications. And on the other side, we also have some projects where we use like a fully managed serverless container platform. This is cool for smaller projects, maybe for startup customers, and also just for a new greenfield project when you don't want to start designing a whole Kubernetes cluster from scratch. Also, on the other end of the spectrum, like serverless functions, I personally find very interesting, but I don't have much experience with that as a main paradigm, more like an add-on to the other two. Okay, why should we do autoscaling, or what is the purpose? In my opinion, the autoscaling's biggest benefit is to save cost and to save energy consumption. But to make it work, we need to have a few attributes that we want. So we should be able to scale both the clusters and the services, ideally from 0 to as much as needed. We want to scale fast, so ideally in real time based on the load that's actually coming in. We also need a low startup time, so that if the resources need to be scaled up, there's no trouble for the users. They don't have to wait. And because we love Kubernetes, we would like to continue using containers on Kubernetes. Now, in autoscaling, there are two dimensions, I think, which are really important. One is, do you scale nodes or workloads? And the other is, do you scale horizontally or vertically? So horizontally means if you need it, you just add more instances, and vertically means you take your instances and just make them bigger, so give them more resources. And I want to give a quick overview of the tools that I know that are popular for both or for all these dimensions. So first, looking at the node level, there's the cluster autoscaler, which is Kubernetes built-in and which is used by many for horizontal scaling. And then there's also Carpenter, which is an open source project that's much more flexible than the standard autoscaler, and comes highly recommended also from our HWS projects, but as I understand, is currently only supporting HWS. So you may be out of luck if you aren't on HWS. And you can also use the various products from the cloud providers directly. They usually offer some kind of autoscaling for the nodes. Usually that means either you get a fully managed Kubernetes nodes where you don't even say what kind of node, or you don't have to take care of it, or you can say that you want to be able to execute some workloads outside of your actual cluster nodes, so like in a spot instance or so. And you can also combine it sometimes. Okay, then switching over to the workloads, so pods and container scaling. The two built-in ones from Kubernetes are the horizontal pod autoscaler and vertical pod autoscaler. Both of those scale based on the memory and CPU usage of the pods, and of course are vendor agnostic and so on. Scale to zero is not possible, at least not usually. So I know that in HPA there's a experimental feature since 2019, so I'm not sure if this ever gets out of the experimental status. But in theory, you can use it with a feature flag, and then you could also scale to zero. So scaling to zero just means that if you have no load at all for some time, then it would really go to 0 instances instead of at least one that you have usually. Then there's KEDA, which is event-based autoscaling. So they provide lots of different event sources that you can use, like database or queue events, and you can scale based on that. Lately, they also are working on HTTP request rates as a scaling criterion, but that's still in beta and is an extra add-on. And then there is Knative serving, which I want to show you today, which scales based on HTTP requests. So to describe Knative as an autoscaling tool would be misleading because it has a much bigger scope. Autoscaling is a big feature, but it aims to be an enterprise solution to build serverless and event-driven applications. And it brings a lot of stuff with it. So looking at the project history, it was originally built by Google and contributions from other companies. Google also used it as the foundation for Google Cloud Run, which you may know. It's a managed serverless container platform. And then in 2021, it also got contributed to the CNCF and is now in the incubating level there. In total, there are, I think, 3 components, 3 modules inside Knative. The first one, Knative serving, is today's focus, which brings a container runtime with HTTP-triggered autoscaling. And then there's also eventing, which brings a routing layer for event-based asynchronous architectures. And there's functions, which aims to be like a cloud-agnostic function framework. So hearing this, you may think, oh God, what am I getting when I take Knative? And I agree. So this is a big package that you get and that you need to adapt to if you want to make use of the autoscaling. So on the right side, we see the data model that it brings. So instead of the standard Kubernetes resources, you will then use the service custom resource, which is Knative's abstraction for a service. And so you don't define the pods or the deployments and so on. You only define the service. And Knative takes care of the other things, for example, the routes and the revisions. So there's also they have their own deployment model. So if you deploy a new version, it will get a new revision, and you can also do things like split the traffic and so on if you want. And to make that work, they bring a lot of infrastructure that you also need to take. Mainly to allow these deployments, so they have an operator to handle that, and also networking stuff. So all the requests that are handled by Knative services, they go through one central ingress, and also each individual service gets a sidecar container with a proxy where the request also goes through. All of that is, for example, used to enable the autoscaling, so you can react very quickly to the incoming HTTP requests. Now let's look at an example. On the left side is a definition for a Knative service. As you can see, it's using the custom resource from Knative with the kind service. The usual stuff, and what you can also do here is define specifics for the autoscaling. How do you want it to behave? So how does autoscaling work in Knative? as I said, it's based on incoming HTTP requests. You have a choice between two metrics for that. One is concurrency and one is requests per second. And the recommended one is the concurrency. That means how many concurrent requests can one instance handle from your service. So if you go over that, it would start a new service instance, and if you go below that, it can scale down the instances. And you have some choices like defining hard limits or soft limits, defining a target utilization. So that means what should the algorithm target for in concurrent requests and so on. And also you can define the scaling bounds. So for example, do you want to scale to 0 or do you want to keep a certain amount of instances running all the time? And do you have a maximum because you don't want to pay a huge bill in the end if some DDoS comes in or something like that? And also you can define some details like the windows, how fast should it react to changes in the loads and so on. One important aspect is if you think about the autoscaling, that it's a bigger way that you need to look at, not just the moment where the workload or the pod reacts or it gets scaled up and down. So there's a great article at learnkubernetes.io where I have this picture from, and it shows like a worst case or a bad scenario, assuming that you get a load spike and you need to scale up, but you also need to create a new compute resource, add a new node cluster to your cluster, a new node to your cluster. So if you look at this and think about what needs to be done for the scaling, it starts with the autoscaler. In this case, the horizontal pod autoscaler could take up to 1 minute 30 to just react to the load and see that it needs to scale up the pod, because it is based on the metrics that are collected every 10 seconds and then stored in the metric server, and there it's only aggregated every 60 seconds, and then it gets checked every 15 seconds. So in a bad case, it can take 1 minute and a half until you even notice that you need to scale up your pod. Then there's the cluster autoscaler. It also has some delay to notice that, okay, here's a pod that needs to be started, but I don't have enough resources. And yet now he needs to decide to even start a new node, and which kind of node. This can also take up to 30 seconds, is written there. And then once you decided you need a new node, you have to ask the cloud provider, now please start me up a new VM and add it to my cluster. And this can also take 3 to 5 minutes. And in the end, if the new node is ready, you still need to start your pod on there. And for that, you need to pull the Docker image. And depending on the size and so on, this could also maybe take 30 seconds again. So when we use Knative, we can mostly eliminate the first part because it reacts near instantly because all the requests go through the proxy. So that's very good, but still the other parts need to be also taken care of. And here are some approaches. For example, for the node provisioning, first approach is, of course, you can use a setup where you don't have to take care of the nodes, or you get just some pre-warmed nodes from your cloud provider. Or you can do over-provisioning. So that means you decide to keep warm a certain amount of nodes that you don't need at the moment, but that can act as a buffer if you get a load spike. So you would have some placeholder pods running, and they have a lower priority than your actual workloads. And if workloads need to be scaled up fast, then it can take the placeholder's place. And in the background, you will start the new nodes to get your buffer back. So if you know how big the load spikes will be, then this could be a good strategy. And for the last part about the Docker images, obviously you should keep the Docker images as small as possible so that the download is faster. You should use image caching, and you can also consider to preload and cache images on all the nodes. So ideally, if a pod is started for the first time on a new node, the image is already there and doesn't have to be downloaded. Now I want to show you a quick demo. I'm using Java for this, not because it's the best suited language for autoscaling, which it is not, but because this is most relevant in our work and for me personally. So I'm using here a project with the framework Quarkus. Quarkus is a cloud-native Java framework, which is aims to have good efficiency and performance. They have their own CLI, and I used that to create this sample project. It's a very simple and boring demo project with a hello service, as you have seen thousands of times probably. We also have a Maven configuration. Here I added some stuff so that it integrates well with Knative. The good thing is that Quarkus has an integration with Knative, so we actually get, when we build this, the deployment descriptor generated by the build. So here this is a Knative service, and it's based on the properties I set in the POM XML. And I'm using native Docker images, so built with the Graal VM. This autoscaling use case is actually one of the most convincing ones to use the native Docker images, because you profit from the very small footprint, so the image can get loaded faster, and you also profit from the faster startup time that you need when you constantly create new instances of the service. Okay, and besides that, I use a local setup with Colima and a micro Kubernetes inside of that. And in there, I have installed the Knative infrastructure. So you can see below here that Knative serving, for example, brings various infrastructure components that are running here and that are required. I will start by deploying the Knative service. So just make sure that, okay, I still have one, so I will delete that first. And we can start clean. Knative also brings its own CLI. This is the kn command here. And I say service apply. This is the namespace, and I give it the YAML that I showed you earlier. And it will create this service inside Kubernetes. And below here, we also see that it starts the first instances of the service. Now I want to test a request. I need a port forwarding. I'll use this one because Knative uses a central network layer. In this case, I chose Courier, which is one of the 3 supported ones. And I started port forward, and then I should be able to make a request against the service. Yes, and I get the answer here, hello from Quarkus. Now, I want to tweak the autoscaling a little bit. What I will do is set the scale window to 6 seconds. So by default, it's 60 seconds. This means how long of a time frame does it look at when it decides to scale up or down. So usually this would be like the last 60 seconds, but with 6 seconds, it should react much faster. And the second thing that I set is the scale target. This is in this case, because we use the metric concurrency, this means that it targets to achieve 50 concurrent requests per instance. So you can see here that we have the two deployments. The second one actually terminated faster, and as you can see, they are both terminating now, scaling down to 0. And I will simulate a little burst here. As you can see, we now have 0 instances of this service. And I want to do 50,000 requests with 120 concurrently. And we can watch below here what happens then. Okay, now everything is gone here from the old ones. And if I do this burst, we can see that it's creating containers. It reacted very fast. The containers are already running. And you can see there are two containers per pod, because there's a sidecar and the actual one. So the test is through. You can already see that it's scaling down to 0 again because of the short time window that I set. And when we look at the statistic, so it took 12 seconds for the whole 50,000 requests. And you can see, this is interesting, the response time histogram. So because I set concurrency 120, the first 120 that were done concurrently, they were like cold requests because there was no instance yet. And this took around 1 second as response time. And all the others took only 100 milliseconds then. But I think that's, this is of course an ideal scenario, but a cold start of 1 second is actually really good. It would be barely noticeable. And as you can see, we only had the containers running for this short period of time where the burst of the load was actually happening. Okay, now you might wonder, will this also work in the real cloud, and how good will it work there? I tested this a little bit, tested it in the GCP. A little bit more difficult to set this up correctly so that it works, but it does work. And I was using a normal Java image in this case because it was a little bit too much effort to create the AMD 464 image on my machine, on the MacBook. So I used the normal image, and this took around 10 seconds for the cold start request. And I would expect it to be 5 seconds or less for a faster image, like a native image or something like Go. So I think this is also in the range where it could be acceptable to really use scale to 0 also in production. Okay, with that, I'll go back to my slides. I only have one more. And this is my summary. So I would say that Knative has really impressive autoscaling, but you can't use it as a simple drop-in, and like with the other autoscaling tools. So the strengths, from my point of view, are it works perfectly for HTTP requests. It is much faster in the reaction than HPA or KIDA. It supports scale to 0, like as a first-class citizen. You can use it along other non-Knative workloads in the same cluster, but of course, this has downsides as well. And it is open source and vendor agnostic. Some of the challenges that I see is it is restricted to HTTP requests, so you can't use it for other things. And the biggest one is you have to buy the whole package, so you need to adapt to the resources and the deployment abstractions that they bring, and you get a whole lot of new infrastructure components that increase your operation complexity. And I imagine that integrating this with your other infrastructure tools that you may have in your Kubernetes cluster could be very challenging, like networking, observability, and security. When to consider it, I would say if you're actually building a serverless container platform on top of Kubernetes, then this could be a real good match. But this use case is quite rare, I think. But it sounds like a great challenge, which would be fun to do. Or if you're building applications, either if you have a high variable load where it really makes sense and you get a lot of out of the autoscaling, or if you have an event-driven serverless architecture and you really want to make use of all the abstractions they have and embrace that. But in both cases, hopefully, you can use a fully managed Knative platform and don't have to take care of this yourself as application developer. Okay, that's my summary. Thank you all for your time. I think we have time for a few questions, if you have any. Yeah. Do you need the micro?
Try now. You mentioned only working with HTTP requests, so if you want to have an event-driven architecture, is there any plan to link it up to any of the messaging systems,
So I think the Knative answer to that is the cloud events, which are then sent over HTTP. Sorry. One back. Cloud events over HTTP asynchronous routing layer. So it will use HTTP in the end. Yes?
You said the proxy will traffic through HTTP in order to trigger the scaling. How is this proxy scaled then? Is it just purely based on CPU or needs to handle the whole traffic?
Yeah, that's a good question. So the question was, all the traffic goes through an HTTP proxy. How is the proxy scaled? So from what I understand, there are 2 points. One point is actually in the user pod, and each pod gets its own sidecar, so that automatically scales with the rest. And then you have your ingress gateway, and I don't think that they have a pre-made answer to that, so you have to take care of that yourself, I think. Yeah. Okay.
Do you actually use the scale to zero approach with Quarkus applications in prod?
Good question. So I have been in a project where we use Google Cloud Run, and so that's not Knative directly, but it's under the hood, and we have used it there in production, but not with Quarkus native image. So I'm not sure. Leander, maybe you have some idea if we use it already somewhere? Yeah. So I'm not aware that we already use it in this model. Yeah.
Okay.
So
Thank you.
just for everyone, so someone commented they use it in AWS Lambda, and it works very well there. Okay. Okay. Thank you very much.